Hi, I'm Geisel. It's the 6th of June, and today I will be doing the pinhole magnifier hands-on lab in the optics unit, where I will investigate the effects of a pinhole device in how my eye focuses on an object. So here I have cut a hole in an index card, and I've taped a piece of aluminum foil over the hole and then made a very small pinhole right here. Okay, now step 2, I'm holding the card near my eye and looking at the light from approximately 3 feet away, and I will move closer to the bulb until I almost touch it, so let's see what happens. Here. Okay, so the words are slightly magnified on the light bulb. I can read 20 watts. Interesting. And I back away, and it gets smaller. Okay. So that shows how I just magnified it with a small pinhole. Okay. Now next step. Okay, so I've made a bigger hole with the tip of a sharpened pencil, so it's greater than the one made by the needle. And I'm going to do the same thing again, starting from 3 feet away and moving inward. Okay, so it still magnifies it, but not as much as the smaller one. I take it away and it's smaller. Interesting. Okay. Okay, number 4, I'm now using my fingers as the pinhole magnifier instead of the index card. So basically, I have to put my fingers together like this, so it creates a tiny pinhole. So I'm going to do the same procedure, just with my fingers instead. Okay, so this works the same as the first smaller pinhole. The text is magnified, and I can see more clearly than just looking at it without the pinhole. Okay, question 1. Create a diagram of the eye to explain how the pinhole device works. Here is my diagram of the eye, and basically the pinhole at the center of the index card blocks out all other light so that the image or text could be focused through the lens of the eye and onto the retina at the back of the eye. And basically this works the same way that LASIK surgery works. When the size of the cornea is adjusted to help people with nearsighted or farsighted vision. Okay, question 2, how does the size of the pinhole affect its resolution? The smaller the pinhole, the better the resolution. So with the smallest pinhole held up close to the text on the lamp, the better the resolution and the clearer the text was. Okay, question 3. At what distance to the object was each device most clear? The closer to the object and to my eye, the clearer the image. With the smallest one, it had to be really close because it was so small, so you couldn't really see the text unless it was right next to the object. And then with the larger pinhole, you had to hold it a little farther back for it to be an effective magnifier. Question 4, the brightness or dimness of the object, it was pretty dim already because it's only a 20 volt or watt light bulb. And as I got closer with a smaller pinhole, the object became dimmer because naturally the index card blocks out all the light, And the last question, how would the pinhole magnifier help a person with nearsighted vision and farsighted vision? Well, like I said, this works sort of how LASIK surgery works, because it makes the cornea smaller. And basically, the pinhole magnifier just focuses the images that farsighted or nearsighted people can't see. Farsighted can't see closer objects and nearsighted can't see farther objects. So if one was nearsighted, he or she could use a larger pinhole magnifier at a distance to see things that are far, and if one was farsighted, he or she could use a smaller pinhole magnifier at a closer distance to see things that are close. The end.